Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 12 math Euclid contest question. It's question 2 from the year 2020, and there's 3 parts to this question, culminating in part C, which was the question on this thumbnail, that says suppose n is a positive integer, and the value of this expression is also an integer. Determine all possible values of n. Now you can skip to this solution in the chapters menu. Otherwise, I'll be right back with all 3 solutions. Alright, so let's start with part A. Part A, we have a 3-digit positive integer m. So let's say m is equal to a 3-digit integer, where the first digit's a, the second digit is b, and the third digit is c. Now it says m is an odd integer. So if m is odd, that means its last digit c is also going to be odd. And we have 3 distinct digits. So that means a does not equal b, and b does not equal c, and so on. And then it finally says that the 100th digit, so a, is equal to the product of the tens and 1 digits. So a is equal to b times c. And then it says determine m. Well, since this is a 3-digit integer, we know that a cannot be greater than 9. And therefore, b and c must multiply to give a number that's not greater than 9. So let's start small. First, we also know that b or c, b cannot equal 1. Similarly, c cannot equal 1. And the reason for that is, if either b or c were 1, multiplied by the other digit would give you a digit a, which is the same as either b or c. So what do I mean by that? Let's say c is equal to 1. Then if b were 4, 1 times 4 would give you 4. And so that would invalidate this here, where it says that they're all distinct. So we can't have that. So let's try with the next smallest. The next smallest would be a 2, but we know that c can't be a 2 because c is odd. So let's try if c were 3. If c were 3, we could multiply that by, well, the next smallest other than 1, which would be a 2. And 3 times 2 would give you 6. So this is definitely a possible value for m. And you can also show that it's the only possible value for m, because the next value for b greater than 2 would be 4. And 3 times 4 is not a number that is less than 10. So this is our answer. Alright, so let's look at part B. Now part B says Eleanor has 100 marbles, which are either black or gold. And the ratio of the number of black marbles to the number of gold marbles is 1 to 4. So the ratio of black marbles to gold marbles is 1 to 4. So she has 4 times as many gold than black. Now, since she has 100 marbles, that would mean she has 1/5 of 100 black marbles, which would be 20. And you can see that in this ratio. If you continue this ratio, that's the same as 20 to 80. And that would give you a total of 100 marbles. So she has 20 black and 80 gold. But what she wants to do is add gold marbles to change this ratio to a 1 to 6 ratio. So if you had a 1 to 6 ratio, that would mean that you need to have 6 times as many gold marbles as black marbles. And since we have 20 black marbles, 6 times 20 is 120. So that is an additional, going from 80 to 120 marbles, an additional 40 gold marbles that she needs to add. Alright, so now we're on part C. So we have n, which is a positive integer, and also this expression n squared plus n plus 15 all over n is also an integer. For that to be true, we have to determine all possible values of n. Well, let's change this expression. We'll divide each term by n. So n squared divided by n is just n. And then n divided by n is 1. And then we're left with 15 over n. Well, since n is an integer, we know that n plus 1 is also going to be an integer. So for the whole expression to be an integer, we need this 15 over n to be an integer. And that's going to happen only when n is a divisor of 15. So we have a couple options here. So n could be 1. In that case, you have 15 over 1, which is an integer. N could be 3. 3 goes into 15 5 times, so that's an integer. You can also have n as 5 or n as 15. So we have these 4 possible values for n.